To today's algebra lesson. As you already know, I'm Mehma Rajmani, and this channel is dedicated to help you understand the math concepts easily and naturally with lots of simple and interesting examples. Mom and Dad, if you are watching this, you have come to the right place. I'm here to help your child improve their interest in mathematics. This series of lessons of algebra is very important and essential for many people working in a variety of fields. So these lessons are specially designed for school children from grade 8 to grade 11. Before we go any further, please make sure you subscribe to my channel and hit the bell icon. With no delays, let's see what I have done so far and let's dig into today's lesson. Lesson 3. Algebraic expressions. Variables and constant. What is an algebraic expression? There are three different ways that we can think about or we can use to generate algebraic expressions. The first one, when representing distantly different items, for example, apples and oranges. If I have two apples and an orange with me, I can take X to represent an apple and Y to represent an orange. Therefore, I can write the expression 2x plus y to represent what I have. If you have not watched my first lesson, please go ahead and watch that so you will have a better understanding. Secondly, when there are known and unknown stuff. For example, let's say I don't know the price of an apple, yet I have 3 apples and $5 with me and want to calculate the value of what I have. For that, let's take A as the price of an apple. Therefore, we can use the expression 3A plus 5 in dollars to represent the value of what I have. Please go ahead and watch the lesson too if you haven't done that. I'm going to put a link here. Thirdly, when there are variables and constants, variables are quantities that vary over the time or vary compared to another quantity. Constants are some fixed amount or some fixed quantities that do not vary. First of all, let's identify whether the given quantities are variables or constants. First, number of chocolate bars in the fridge. It varies over the time. Sometimes I go and eat one, sometimes my sister does. My mother go to shopping and fill the fridge with chocolate bars. It does vary. So we can identify it as a variable. Secondly, the time I wake up in the morning. I do not wake up at the same time. Sometimes 7 o'clock, sometimes 8, sometimes 9 o'clock. So it is also a variable. How about the monthly charge of a postpaid mobile plan? Does it vary over the time? No, it does not. Because it's a postpaid plan and I have to pay a fixed amount. It is a constant. How about the number of eggs a hen lays? We all know that it depends from time to time. Therefore, we can identify it as a variable. Here's my first example. I'm going to see how to calculate any bill, electricity bill, the gas bill, or the telephone bill. So when we talk about such bills, they have usually a fixed charge that I have to pay for the monthly supply charge or the documentation and administrations, and a variable charge that actually depend on my monthly usage. So in terms of electricity bill, there are two types of variable charges. One is the general usage and other is the control load, which have different unit costs. Let's see how to calculate the electricity bill this time. Suppose my provider charged $30 of fixed amount each month, while 30 cents and 20 cents per general usage kilowatt hour and control load kilowatt hour are used respectively. Now I want to write an algebraic expression to represent my monthly bill in general, because it change from month to month. So we're going to write a very general formula that I can use for any month. Since there are two variables, general usage and control load, I need to define two variables for them. I define X as the general usage while Y as the controlled load. Now we can write our expression. We can start with 30 because we have to pay $30 each month. It's a fixed amount. And I know the general usage cost 30 cents, and if I use X number of kilowatt hours, I have to pay 0.3 times X amount. And I have to add how much controlled load cost. If I use Y amount, which cost $0.2, it is 0.2 times Y. So our expression is 30 plus 0.3x plus 0.2y. In the last month, if there were 50 kilowatt hours of general usage and 150 kilowatt hours of controlled load, what is the amount I had to pay? Now we know the value of x and y for a particular month. So in the last month, x was equals to 50, while y was equal to 150. Now we can plug those values to our expression to get how much the bill was. 0.3 times 50 for the x and 0.2 times 150 for the y. I can simplify this again. 30 plus 0.3 times 50 is 15. 0.2 times 150 is 30. Altogether, we can add them up and it's 75. $75 because everything is in dollars. Before we go any further, let's look at the components of an algebraic expression. It can have numbers like 30 in this expression, and we identify it as the constant. And we can also have 0.3x, 0.2y, these type of terms, and they are algebraic terms. And in this expression, we have two variables, x and y. 0.3, 0.2, we call them as coefficient. And also we can see the plus sign. Sometimes you can have the minus sign or the multiplication or the division. So we can also expect arithmetic operations. So in an algebraic expression, we have constants, variables, coefficients of the variables, and arithmetic operations. The example 2. I'm going to calculate the pocket money that kids received in a family. I'm going to do this in a very general way, which I can apply it for any family in the world. For that, I'm going to categorize four things. In a family, let's suppose there are X amount of girls while there are Y amount of boys. So altogether, they have X plus Y amount of kids in a family. Suppose mother gives A amount of dollars for kids per week, while father gives B amount for the kids per week. Since it's very general, the x, y, a and b depend from family to family. I'm writing it in a general way. Now let's obtain an expression to represent how much pocket money kids received from their mother per week. We know that it's in dollars, of course. A amount she gave to her kids. They have x plus y amount of kids. So A times x plus y. How about the money that they received from the father? Father gives B dollars for each kid, and there are x plus y amount of kids. Finally, how much pocket money kids received from both mother and father a week? Mother and father together gives A plus B amount of money, and that's for one kid, and in the family there are x plus y amount of kids. So it should be A plus B times x plus y. Again, it's in dollars. This expression we can also obtain in a different way. It's simply the addition of what mother gives and what father gives. So this algebraic expression should be exactly equal to A times x plus y plus B times x plus y. Now let's look how to multiply algebraic expressions. First, let's see how an algebraic expression can be multiplied by an algebraic term. For that, let's look at what the kids receive from their mother. It's A times x plus y. And here, A is an algebraic term. All we need to do is we have to distribute. So, the amount that mother gives to girls, and then the amount that the mother gives to boys. So for girls, she gives A times x, and for boys, A times y. So the expression A times x plus y, we can write in another form as A times x plus A times y. If we have x plus y multiplied by A from the right, which is this. Again, we can do the same thing. We can distribute A to x and to y. We get x times A plus y times A. But multiplying two numbers, x times A is same as A times x. Y times A is same as A times y. This is equal to this, and this is equal to this. Therefore, I can write this expression is same as x plus y multiplied by A from the right. Doesn't matter, the order doesn't matter. Now let's look how to multiply an algebraic expression by another algebraic expression. For that, I have chosen A plus B times x plus y. A plus B is the amount that mother and father give to one kid, and x plus y, the number of kids. I have already told you that we can write it as A times x plus y plus B times x plus y. What I have done is I've considered the x plus y as a single term and distribute it to A to get this, and then distribute it to B and obtain the second term. And now I can distribute A to x and y to further simplify. So A times x plus A times y. And in the second, term, I distribute b to x and y. So I get b times x plus b times y. So a plus b times x plus y can be written in another way as a times x plus a times y plus b times x plus b times y. To get into this, I had to go through this step, but that is an unnecessary step, and I will show you an easy way to do this. So when we multiply these numbers, I will first multiply the first number, which is a, in the first expression, and with the first term in the second expression, a times x. What I did was I multiplied the first with the first, and then I can look the outer one. A and y are outer, so a times y. It is the outer bit. And next, the inner. B and x are inner. B and x are in inner. So b times x. That's the inner part. And finally, the last. Last, I have b in the first expression and y in the second expression. The last. So b times y. And I have to add all of these terms together. What we did was we foiled it. F-O-I-L. First, outer, inner, and last. We multiply terms in the first, outer, inner, and last order and add them together to simplify the algebraic expression multiplied by another algebraic expression. In summary, I explain how to create algebraic expressions when there are varying and fixed stuff. This is the most common way of learning algebraic expressions, and where we look into the problems in a very general way. Also, I explain how to multiply two algebraic expressions using the FOIL technique. With this knowledge, you are now able to create and deal with algebraic expressions for a wide variety of problems. Hope you enjoyed my video. If you liked the video, please click the like button and share it with your friends. See you on the next time. Bye.